Good morning and Jai Hind, dear students. I hope you all are preparing well for your exams. Children, as you know that we have completed this chapter and we have done the book exercise already. Now, today we will do the exercise that is short answer question, long answer question in HOTS. I have already sent you these answers in the school app. So after the class, please go to the e-content and you can find the answers there. Children, in the answers, the diagrams that are mentioned just below the answer, you have to draw it on the left hand side of your notebook, that is on the plain paper. Okay, so let's quickly start with the discussion of exercise, that is question answer, short question answer, long and HOTS. Okay, so now I'm going to share it. All right, so starting with short answer question. All right, so short answer question, question number 1. Why does a free suspended magnet points in north and south direction? Children, we already know that whenever we suspend a magnet freely, then it always points towards north and south direction. Isn't it? It always points toward that. Now, what is the reason behind it? You know that what is the reason is that whenever we are suspending a magnet freely, it just stands just opposite to the geographical north and south pole, because we know that earth itself acts as a magnet and it also has its own south pole and north pole. Okay, so magnet just stands opposite to that, just opposite to the geographical north and south pole. Okay, so let's see. Freely suspended magnet points in north and south direction. This is because the earth itself behaves as a huge bar magnet with its magnetic pole near the geographical north and south poles. In a freely suspended magnet, the north pole points towards the geographical north pole since it is attracted by the earth's magnetic south pole, isn't it? Because it is attracted by the south pole, so it is standing towards the south pole, like away from the south pole. Similarly, the south pole of the suspended magnet is attracted by the earth's magnetic north pole and therefore points towards the geographical south pole. Okay, so that is why the magnet stands just opposite to the geographical north and south pole. So this is the reason why the magnet always freely suspend in the direction of north and south. Question 2. What will happen to the poles of magnet if it is broken into two? Children, we know that even if we broke it into several pieces, even if we break it into thousands pieces or lakhs pieces, even the smallest magnet also has its north and south pole. Okay, they also has their north and south pole if we are talking about a bar magnet. Okay, so we will get two separate magnets, each with its north and south pole, and children, you will draw this diagram in front of this answer. Okay, now question number 3. Will a strong magnet attract a piece of copper? Why? Will a small magnet will attract a piece of copper? Children, copper is a magnetic substance or a non-magnetic substance? Copper is a non-magnetic substance. So magnet will not get attracted towards copper. So answer is no, because copper is a non-magnetic substance. But if in any case in place of copper it would have been iron, then वहाँ पे magnet attract करेगा, क्योंकि copper था and copper is a non-magnetic substance, the magnet will not attract. But if there would have been iron, nickel, cobalt, it will attract. Okay, magnet will attract because they are magnetic substance. Now, question number 4. State the rule for attraction and repulsion between two two magnets. So what is the rule, children? We know that like poles attract. Yes, no. Unlike poles attract each other and like poles repel each other. Unlike poles attract, unlike poles attract, whereas like poles repel each other. Isn't it? Unlike poles attract, that is north and south pole will attract, whereas south pole, north pole will repel each other. Okay, this is the rule of attraction and repulsion. Question number 5. One precaution you should always take while handling a magnet is not to drop it. Why? Children, whenever we are handling the magnet, we should not drop that magnet. Neither from the height, neither from, we should not drop it. Why? Because the magnet will lose its magnetic property. The magnet will lose its magnetism. Okay? That is why we should not drop it. So the answer is because the magnet loses its magnetism. Magnetism is a property the magnet is having to attract and repel. Okay, so because a magnet will lose its magnetism if it falls from a height. Okay, now question number 6. Why are magnetic keepers used to store magnets? Why are magnetic keepers used and what is magnetic keeper? So this is a magnetic keeper which is made up of iron. Here also, this is a magnetic keeper which is made up of iron. Now, why this magnetic keeper is used? The magnetic keeper is used to store magnets in order to avoid self-demagnetization. अपने आप ये मैग्नेट अपना मैग्नेटिज्म ना खो दे, इसलिए हम उसमें कीपर्स को अटैच करते हैं. And what is keeper? Keeper is made up of iron. And between the two bar magnets, we put a wood. So this is a wooden plank. ये आप देख रहे हो, this is a wood. Okay, so we keep a wood between two magnets. Why we keep a wood between two magnets? Because wood is non-magnetic substance. It cannot conduct magnetism, neither it cannot conduct electricity. Okay, so that is why we have kept a wood in between the two magnets, and keeper which is made up of iron is kept at the side to make it intact. Clear? So this is done to avoid self demagnetization. Self demagnetization मतलब self का मतलब होता है खुद, demagnetize मतलब magnetism की property lose करना. Okay, so the magnet when it is kept for a longer time can lose its magnetism. Okay, so to avoid it we keep the magnet in the keeper. Okay, so that was about the short answer question. Now moving ahead with the long answer questions, children. Long answer question number 1. How will you experimentally show that there are two regions in a magnet where its magnetic strength is concentrated? So what is the question saying? You have to prove it experimentally that if there is a magnet, so its magnetic strength is concentrated at two ends. तो ये हम कैसे prove करते हैं? So there is experiment. What we do in that experiment? We take some iron fillings, okay, and spread it on a sheet of paper. Roll the bar magnet in the filling. Bar magnet, we take a bar magnet and we'll roll it over, okay, and then lift it up. फिर हम उसको उठाएंगे. Then what we will find that the iron fillings are stick to the magnet at the ends. So we have seen this diagram in the book that if this is a bar magnet and these are the two ends, that is north and south, so all the iron fillings will be sticked at the ends of this bar magnet. Okay. So thus in a bar magnet, the regions of strongest magnetism are near the ends. तो सबसे ज्यादा मैग्नेटिक स्ट्रेंथ कहाँ होती है? एंड पे होती है. Okay. And they are called poles of magnet. How many poles of magnet are there? Two. North pole and south pole. Okay. Now question number 2. Show diagrammatically two ways in which a magnet can be freely suspended to locate directions. So you have to show it diagrammatically. So it is there in your book, children. You have to draw this diagram. Okay. So these are the two methods. This is A and this is B. Okay. So these are the two methods by which we can show a freely suspended magnet. First is to tie the bar magnet with a thread. ठीक है, आपने एक थ्रेड लिया, उसकी स्ट्रिंग्स बनाई और आपने मैग्नेट को टाई कर दिया. This is one way. Another way is you will take a bucket, put a water in the bucket, you can even put like a small box of plastic or just put a cork. Okay, so just put a cork over it and just put this magnet over this cork. So after some time what you will see that it will automatically take the direction north and south. Okay, so these are the two ways through which we can freely suspend the magnet. Now question number 3. Give the step-by-step method you will adopt to test if a piece of magnetic material is a magnet. I am again repeating the question. Give the step-by-step method you will adopt to test if a piece of magnetic material is a magnet. Children, to prove that any magnet, any substance is a magnet or not, what is important? Attractive property or repulsive property? Repulsive property is important. Why? Because even iron can attract. तो हम ये कंफ्यूज हो सकते हैं कि whether it is iron or it is a magnet. So to make it confirm or to make sure of it, what we have to do, we have to see whether they are repelling it or not, where the like poles are getting repelled or not. Okay, so repulsion is the important phenomenon. So let's see what is written. What we have to do is bring one pole of a magnet close to the ends of magnetic material. हमने एक मैग्नेट लिया, हमने दूसरा एंड एक मैग्नेटिक सब्सटेंस के पास ले आए, one end at a time. If one end is attracted and the other repelled, the magnetic material is a magnet. If both ends are attracted, the magnetic material is not a magnet. I am explaining it to you, children, just a moment. So if this is certain magnetic substance, ये क्या है? कोई मैग्नेटिक मटेरियल है जिसको हमें प्रूव करना है कि whether it is a magnet or not. So what we are going to do, we'll take a magnet, we'll take a bar magnet, we'll put one end here. Okay, so it should attract or repel. So if consider this north pole is attracting, then we will put a south pole here. Then south pole should repel, isn't it? So to prove that it is a magnet, one pole should attract and other pole should repel. Then only it will be a magnet. If both poles are attracting, so this material is not following the property of a magnet. Okay. So by this way we will prove that a magnetic material is a magnet or not. अगर दोनों pole attract कर रहे हैं, then it is not a magnet. If one pole is attracting and other pole is repelling, then the substance will be called as magnet. Okay. So this is a condition to test the magnetism or test a magnet. I hope it is clear, children. Now, question number 4. Given a bar magnet, describe the method you will use to magnetize an iron nail. So children, we know that the procedure to magnetize is known as single touch method, isn't it? This method is known as single touch method. And what happens in single touch method? We take a iron nail and we take a bar magnet like this. We take a iron nail, we'll take a bar magnet. From one end, we'll tap and move. Tap and move. Only with the one end. Okay? And we'll repeat it for 30 times. Isn't it? So when we are repeating it and then again if we'll see it, then it will behave like a magnet. So let's see what is the activity. Place an iron nail on a bar or a table, okay? Hold it down firmly and stroke it about 30 times. We'll stroke and turn from one end to the other with one pole of a bar magnet, only with a one pole. After you reach the other end, lift the magnet high and bring it back to the first end. You will find if we stroke with the north pole of the magnet, the end of the iron bar from which the stroking has started becomes the north pole and the other becomes the south pole. Okay? If we stroke with the south pole, poles in the needle will be reversed. Okay? अगर हम north pole से stroke कर रहे हैं, then this end will become north and this end will become south. If we are stroking it from the south pole, then this end will become south and this end will become north. Okay? So by this way, this is called single touch method. By this way, we can convert any substance into a magnet. Okay? So this is the activity. Okay, though nowadays this is a traditional method, we don't generally use it. Nowadays electrical current is passed to form a magnet. Okay, now question number 5. Name and describe the instrument that uses a magnet to find direction. Repeating it, name and describe the instrument that uses a magnet to find direction. So what is that instrument called, children? It is called magnetic compass. Isn't it? It is called magnetic compass. So let's see. So the answer is magnetic compass. So a compass consists of a magnetized needle pivoted at a point so that it is free to rotate about. So we have seen what is a magnetic compass looks like. So if this is a magnetic compass, I'm not that good. This is the center where the needle is placed. Okay, so it will point towards north and south direction. Okay, so this is a magnetic compass. It also has several different directions. Okay, so it is pivoted at the center at a point, but the fixed है एक point पे, so that the needle can move. Okay, so when you will keep it aside for some time, it will always point towards north and south direction, provided it is kept away from the magnet or other magnetic material. Okay, so answer is magnetic compass. Now, last question of long answer question, that is question number 6. List any 3 uses of magnet. So what are the 3 uses of magnet, children? Quickly. So where are magnets used? Magnets are used in refrigerator, for door stickers. It is used in electric motors, used in fan and other electrical appliances, in a speaker, microphones, picture phone of television and computer monitors. Okay, so even they are used in ATMs and solar panels. So there are n number of users mentioned in your book. So you can write any three or you can write these three. Okay, so it is used in refrigerator, it is used in electric motors, used in fans and electrical appliances. It is used in a speaker, microphones, picture tube of a television and computer monitors. Okay, so this you have to learn. So these were the short answer questions and long answer questions. Okay, now let's quickly move to the HOTS question. We have 4 HOTS question. Let's discuss question number 1. Before invention of the compass, sailor used star to find directions. Yes. In what way is using a compass better? Earlier children, when there was no magnetic compass, so sailors were not able to see the direction, which is north, which is south, and which is east and which is west during night. दिन में तो पता चल जाता है because of the sunrise. Okay, but during night they were not able to see it. So they used to see the star, the direction of a star, and then they used to find the direction. Okay, so now why compass is better than seeing the star and a moon? Because during cloudy time, when there is cloud, the person cannot see star, isn't it? अगर बादल होता है तो हमें stars नहीं दिखते हैं. That time what the sailors will do? So that is a question. Okay, so let's see what is the answer written. So compass is better as it can be used at any time of the day or night and in any weather. We can use a magnetic compass in any weather, in day or night, anytime, every time it will show a perfect direction. Stars can only be seen at night on a clear night. ठीक है, अगर बादल साफ है, धुंधला नहीं है, कोहरा नहीं है, then only we can see a star. So they cannot be used during the day or in the cloudy nights. Clear? So that is why compass is better than seeing the star. Now question number 2. Will a pair of bar magnet with keeper on the two ends acts as a magnet? Try out and see for yourself. So question says, will a pair of bar magnet with keeper on the two ends, अगर हमने keeper दोनों ends पे लगा दिया है and we have a bar magnet, so will it act as a magnet? No, definitely it will not act as a magnet. Why? Because they will not conduct the magnetism. ठीक है, इसीलिए हम उसको कीपर में रखते हैं कि they will not show that magnetic property. Okay, so the answer is no. Next, maglev train is a type of a train that moves while floating in air just above its track. This way, friction is minimized and the train moves very fast at a speed exceeding 5,000 km per hour. How do you think it is made to float above the rail? Children, there are some trails that are called maglev trains. Okay, so this maglev trains, what happens? They are a bit higher from the track. थोड़ा सा ऊपर होती है track से, ठीक है? And they move very fast. Even the metro also follow the same principle. Why metros run very fast? Why these bullet trains run very fast? Because they are a little above from the track. ठीक है, तो जब वो ऊपर होते हैं तो फ्रिक्शन बहुत ज्यादा नहीं लगता है and they have a free flowing. Okay, so what is the reason? कैसे चल पाती है ये? So it is by repulsion of light poles of powerful magnets. So in that train, powerful magnets are used. So when there will be a same pole hoga, so there will be a repulsion and there will be a repulsive force acting. So because of that force, these bullet trains and maglev trains and everything, they are moving so fast. Last question. Given a bar magnet, how will you find the west direction? अगर आपको बार मैग्नेट दिया गया है, so how you will find a west direction? So children, first we will suspend the magnet freely. So if we suspend the magnet freely, so it will show us north and south direction, isn't it? So when it will show the north and south direction, we can easily find that from the north direction to the left, this is the left, to the left we have west, and to the right we have east. Okay, so let's see. We will suspend a bar magnet freely. It will align itself in south and north direction. Correct. The north pole of the bar magnet points towards the north direction. Now with the reference to the north direction, we can find the west direction. Definitely इधर north है, ठीक है? If this is north and that is south, so from north the left hand side is west, and from north the right hand side is east. Okay, so east, west, north, south. Okay, so by this way we can find all the 4 directions. Clear? So that was the exercise, children. Please do write these exercise in your notebook and learn it. Okay, children, first you will learn, choose the most appropriate answer, then you will focus on very short answer question, and then accordingly to short and long answer questions. Okay, so that was about the exercise of this chapter, that is fun with magnets. Children, prepare well for your exams. Questions are very easy, paper is not that tough, but you have to attempt it very clearly. So read the questions very carefully, children. Questions can also be from within the chapter. It is not necessary that it will directly come from the back exercise. It can come from the middle of the chapter. So please first read the chapter, try to attempt the question answers and learn the question answers. Okay, so that's all for today's class, children. Hope you have understood it. So all the very best for your exams, and prepare very well, read all the questions very carefully. So that's all for today. Thank you and Jai Hind, children.